Well, there's a lot of you out there that have got these paraffin inverters, and a lot of people are suffering with a fault called E4. Well, the manual will tell you to clean the filters and clean the fuel and make sure everything's tickety-boo there, as I'm sure you've done, but you'll continuously get in the E4 fault, and that stops everything from working. Today I'm going to show you exactly what causes this E4 fault and how you can get around it and correct the problem. So, with no further ado, I'm going to take this heater and we're going to strip it down. Right, so the first thing we got to do is make sure that the fuel tank is out and the unit is turned off or unplugged. I don't need it unplugged because I've got it running from an isolation separation, and now we start to strip it down. I'll take two screws out the bottom here. On each side. Lift the front off. Undo the two screws that hold the louvers on. Remove the louvers. I always put the screws in just in the lip at the bottom here, so that you can get hold of them easily again. Once that's off, take the 4 screws out. Note that some of these are self-tapping screws and some of them are threaded. The self-tapping screws hold the louver on, and the threaded screws are what hold the bottom on and the top on. And in a minute we're going to put the bottom 2 screws back on for stability, because these things are made out of such thin tin that they just bend around all over the place, and you mustn't over tighten these screws either. Right, this lifts off. Just take the cable and ribbon cable out like that. Just put it on the floor. Now then, we're using 2 threaded screws. Secure the bottoms back on. Okay, now you've got access to everything, and it should all become quite easy now. You do have to take this screw out. You'll see why in a minute. Rotate it round. You get a good view of the back. Remove the 4 screws that hold the fan assembly on. Now, this unit's been recently serviced, so there isn't going to be a fantastic amount of dust in here. But when you get this far, clean the dust off the fan blades and anything around here. And you'll see these 4 screws. Just take them out. This is going to give you complete access to the combustion chamber, and that is where your problem lies. God damn it, I always drop a screw. Never mind, I'll find that screw in a minute. Right, rehang this fan unit so it's there. Assuming you've cleaned all of this, and you've got a nice clean fuel supply. Let's undo these plastic clips. Now for speed, I have slightly modified this so that all the wires that go to the combustion chamber have got green tie wraps around them, the rest have got red. So once with green tie wraps around, we just unplug and they come away to one side like that. Get a wrench or an adjustable spanner, fit it on the oil feed, and unscrew it. As soon as it's loose, you should be able to do it with your fingers. There we go. I hope you can see that oil feed. That's just a nut there. I'll see if I can zoom in a little bit. There's off of this copper pipe, which you really don't want to bend. You get yourself in all sorts of trouble if you bend that. Remove this rubber tube. Get that down. Right, we should be free to lift out our combustion chamber, which you lift right and slide it out. This gives you ample opportunity to clean out any dust that's in this cavity. This is the blower for the flame down here. This is the fuel tank. This is the fuel tank pump. It's a DC regulated pump. You may have noticed that there's extra bits on here. There's this, see if I can show you this. There's a black box here and a wire that hangs around there. That's nothing. It's all it is it's a remote control. I fitted a remote control to this heater so that I didn't have to go over to it to turn it on each time. It's just sheer laziness on my part. Right, and now you've done that, you've finished with this bit, so we'll just lift this up, put it on the floor. This is the bit that is, believe it or not, causing you all the trouble with your E4. So let's get involved. There are 4 screws. These are self-tapping screws around the outside. start off by removing them. It's all very flimsy tin, but it all sort of holds itself together. It's quite surprising, really. Okay. All four of them are removed. Then remove this. Stand it out of the way. Because, what it is it's the direction. The fan goes in there and blows the hot air from this out the front here. So all it does. This is your combustion chamber, held in by a couple of clips. So we just undo these clips and remove the top of the combustion chamber. This is where it gets interesting. Well, I think it gets interesting. Although, I don't know if you can see in there. I'll put a light in there so you can. But this is where your problem lies, on this thing called, it's a rod, it's called a flame bar, and what it does is when there's a flame from the burner going to the flame bar, ions can travel backwards and forwards, and so that knows when the flame is on, and if it's a white flame it's less ions, and if it's a blue flame it's more ions. So it in actual fact can regulate the actual flame as well as being a safety feature. Whereas if the light goes out, the burner goes out, this will sense that the burner's out instantly and shut the fuel off. And believe me, you want that to shut the fuel off. So that's an important thing. And on the other side is just a spark bar to gain ignition. But we'll get into this a bit more now, because this one's got a slight problem on it in the way that it's got a missing gasket. So this is the sparking unit for the ignition, and we're going to take that off, because if we don't take it off it'll still be held on by two wires, but if we don't take it off it will this part gets bent over and snaps off, and when that snaps off it's US, that's it, it's the end of it. It needs a new one. This is where the spark goes in to the ignition chamber, and that just pulls off like that, nice and easy, no problems at all. This is an emergency cutout right here. This cuts out if this overheats, so we take that off because we don't want that getting bent like that. Put the screw out of the way, and it just lifts out. This is a temperature sensor. This senses the temperature of the well, and the well is heated by these two electrodes that are just the same as what you have on a cooker. They go around and return. They heat the paraffin, the well up, so that when the paraffin's injected it turns into a gas, and then it can ignite. Once it's ignited, the heat from the paraffin burning keeps the well hot. This turns off. Well, you don't want to get your hands on this thing because those two terminals there, when it's turned on, are live, and it's at 240 volts. So if you get your hand on those, you're going to wish you hadn't done it. It's going to make for a bad day. Right, deep down in this hole, see if we can get you a decent view of it. There's 3 screws holding on the burner, the actual burner diffuser. There's 2 screws holding on, one there, the flame rod and the igniter, and there's 1 screw at the front here. You need to whip that one out. This one screw at the front. The gasket that's missing on this, we'll be making a new one. I'll show you how to go about that. That's pretty straightforward. Now take out the 2 screws, one that holds the spark igniter in place, it's quite difficult trying to do this and watch a monitor at the same time to see that it's possible for you to see what it is. There's the spark igniter. It's sooty, but we'll clean that off. And there's this bracket for holding it in place. Now we're going to take out the flame rod, which is the sensor. It to all intents and purposes, it makes no sense that it's a sensor because it's isolated from Earth, and it comes up and it sits there by this flame disperser, but it doesn't touch it. It mustn't touch it. It mustn't touch it at all, and so you kind of think, what the hell's the point of it? You'll see it getting red hot when the burner's running, and you may be deceived into thinking that the hotter it gets, the better it is, that it's a heat detector. It's not a heat detector in any way, shape, or form. It simply sits on the point where the blue flame has its point, its hottest point. It sits there, and the ions can run across, and that's noted. And later on, when it's all together, I'll show you how to read this sensor to see if it's any good. And I'll also show you a way around this sensor, but it's not to be. You don't do it lightly, because this can really cause problems if it's sensors. If you bypass this sensor and you have a flame out, that's going to keep on pumping paraffin until the temperature sensor down the bottom realises the temperature's too low, and that could be a good 10 minutes. And believe me, 10 minutes of paraffin is going to be running everywhere. You don't want that. But anyway, that's the flame sensing rod, and this is another one from another boiler flame sensing rod, readily available off of eBay. Although not in this country for some reason. For some reason you can buy them in America, but they're not around over here. Okay. there are 3 screws in here. I'm going to try and move this camera so that you can get a view. Right, there we go. There are 3 screws in here. One there, one there, one there. You'll also notice on this top plate there's an arrow. That arrow always points to the sparker. Must point to the sparker. So we've taken off these 3 screws and remove them. I warn you, though, when you're tightening these screws, be patient and be careful how you go about it, because you can strip the aluminium threads very, very easily once they strip, unless you drill them through, which I don't think you can do actually, but that's the end of your burner. Okay, I think they're just about loose. Maybe not. This is your disperser. There's also a large metal ring inside for stopping the flame from going outwards and making it directional upwards. This is also your disperser for the burner. And now, if you remember the first screw we undone, we can undo this and remove this. This is the earth wire right here that is very important, because without that, that earth goes all the way to this burner, and then your flame rod sits against it, and that's where the ions can charge across from one to another. Right. Give it a wipe out, give it a clean down, this, and then put it to one side for now. Now we've got our separate configuration of parts on the bench, and we can see what we're doing with them at last. There are the 3 screws from the burner. This is the plate that gets hot via these 2 electrodes. As you can see, it's just a simple round and a bit like a cooker. There's your 3 screws which go over the burner is underneath the screws, so if you bugger the threads up here, you can't drill a hole through and put a nut on the back, because you can drill a hole straight through this. So if you do bugger that up, you are buggered. Okay, I'm going to just take out the jet now. So a couple of screws. This is where the blower blows in from the bottom. And there we have it. This is your jet. This needle on the end here. It's a V-shaped needle. I don't know whether I can get that into. If you just see it somehow, but there is a V round into the end of it, and this part goes straight onto here, straight onto this pipe. In fact, I don't need to take this off, but I'll take it off just to show you the configuration and not to bend it. That's a support. And that's how it is. That screws onto your pump. That injects the paraffin into this hole. The air is blown from down here into it to disperse it into a spray into this pot, which is very hot, and that turns it into a mist. That mist is then ignited, and vroom, away you go, as it were. So we'll put these bits to one side, and we'll look at our troublesome parts, and we'll find out why it's troublesome. Now these flame rods were invented for gas burners, and in their infinite wisdom, I don't know why, they've decided to use these on a paraffin burner, which is madness, because on a gas burner the flame is very clean. You can see by this rod here, it's still very, very clean. The gas is very clean, but on a paraffin burner there is a certain amount of soot. Now that soot goes onto this flame rod, and it builds up a resistance to the flame. Because it's got a coating on it, it stops the irons from getting across from one to the other. So that gives you your E4 fault. That is all it is, that little bugger there. So I'm going to stop the video now, because this is going to be cleaned up. When I say cleaned up, some 400 sandpaper, and sand it all over and make it nice and clean. So I'll just stop this, and we'll come back to this after I've cleaned it, because it's just laborious to watch. Okay. Okay, there we are, both cleaned up. I've cleaned the spark eroder as well as the flame rod. It's very important. The bit that's facing the burner has a very, very clean face, which this one has now. And we must not forget the burner itself, with a fine mesh around it. This is also got to be cleaned so that you can see shiny metal all the way through it. So you've got to go around this thing laboriously with 400 paper. I'll save you that, so I'll just pause it here. Okay, now we have a clean surface all around here. A clean surface means that there's metal showing, so that now when your flame rod sits near to this, as soon as there's a flame between the two, ions flow, and the system knows that there's a flame there, and also can gauge its quality of flame. Now, you may have heard me say earlier on that this is missing a gasket, and it sure is. And this burning bowl, yeah, has got black soot on it here and here. Now that shouldn't be there, and that's because of an air leak. So we're going to clean this off, this black soot off, and then we're going to make a gasket. Now, making a gasket is a laborious task, so I will show you it, and then I'll probably speed it up a little bit. Let me just go and get the bits and pieces that I need. So, I bought a whole load of these trays from the pound shop, and I'm only going to need one to do this, unless I completely bugger it up, which is not unknown. Now, first of all, we're going to cut out the diamond shape in the middle. Because that's the bit we're going to need. We'll just dispose of this. This, however, is plenty big enough for a gasket. A gasket that goes on there. Now, first of all, we've got to mark out our gasket. Now, this is a burning chamber. This is the diffuser, first stage diffuser. This gasket has got to go over that diffuser and just outside of the wall around here. So this is going to be mind-numbingly boring to do. So we'll make a start anyway. Place the burner in the centre. Try to keep it over this side so you can see. Place the burner in the centre and secure it there like that. Then just rub my thumb around the edge until I have a circle. Now we cut it out. These are a pair of half round scissors. They're surgeon's scissors actually. I think they're for eye surgery, I'm not quite 100% sure. Now I'm going to have to look at this through my magnifier because my eyes aren't that good. So let me just move the camera. And see if I can get it in the right place. Okay. Move out there. Right. Make a small incision somewhere near the edge. cutting it around to the outside edge of the mark. You'll have to go and tidy it up a bit afterwards, but the main thing is to get this to be a snug fit on that first diffuser. You may not have to do this, because if you're careful removing it, sometimes you don't break the gasket. In fact, it took me 3 attempts before I managed to break the gasket. And in reality, you don't have to take this part of it apart. If you leave the bowl and everything connected inside the flume, you can get a bit of sandpaper and go around the flume, the dispenser, this part here. You can get a bit of sandpaper when it's fixed in place, and then just undo one screw and take out the flame rod. So you don't have to take this apart to this degree. I'm just showing you, because if you have and you've buggered the gasket, then you may want a little bit of insight on how you can get it back together again. Okay, here we have it, and it fits nicely. Excuse all the shreds. There it goes. Absolutely perfectly on that. Okay, next thing to do is there we are. Let's try and get that straight. Next thing to do, plop this in here. Very simple way again of marking it. Rub your finger around the very outside. You'll find, of course, there's 3 gaps for screws. Don't worry about them. What's important is to get your finger marked around the outside. Then you just rotate the sensor like that, and the outer, and where the screws were, now you've got a solid piece to push against for marking. Remove the gasket, drop it on the floor. Here it is for its markings, and now cut out the outside again with a pair of scissors, half rounded scissors if you can. I'll save you this because it's boring as hell, so I'll just pause this. So, with a little bit of time and patience, ta-da, one gasket. That goes around here, like that. Of course, you'll notice that it overlaps the screw holes. There is only one way this can fit on, and that's this way. it's the only way, because it's offset all the threads. Threads are offset, so if I show you it will go on that way, it won't go on that way, it won't go on that way, but it's happy to go this way because this points to the ignition starter. So we plop this back in again. And that's centered. We put this on here, so it's centered over our screw holes. Take a pen with light pressure, we fill in where the screw holes are, the half circles. This of course will make this gasket one directional, that it can only go on in the one way. Again, I'll save you the boredom of all the cutting out, but there are our marks. Soon, just about, and we're going to cut them out little U-shapes. Just in case you're interested, cut these out with a circular cutting tool, and we just place it halfway over the U. We just cut it out, and we do that for all three. Lovely. Now then, this should now be a very directional fit. Which I'm going to line up to the ignition. Like that. That is the ignition hole there. So I'll just put a little arrow on there. Can't get it wrong then. Right. Let's get the rest of this set up. This burning chamber, it should be clean and free from lumps. When I say lumps, I mean there is a lump there that's built into the actual die-cast aluminium, but free from carbon deposits and lumps. I'll see if I can stick a torch in there so you can see in there. Okay, so that's free of lumps. And this is where your needle comes in, just here. We'll go into that in a minute. Right. This diffuser can go into this bowl and rotate and rotate and rotate and rotate and rotate. It's got no key mark. However, there is a little dimple on the diffuser. Just there. That again should be facing the ignition. the reason it's facing the ignition is that you get more gases come out of this hole and this hole for the ignition and this hole for the flame rod. Okay, so let's get this sorted out. Well, it may not look it, but I've had a quick tidy up. Okay, so we've got a disperser on, gasket on, and this is the burner, which we know fits only one way. And that'll be that way. Now, this gasket that you put on is going to bend up because it's flat like that. The burner's on the inside of the moulding, so when you push the burner down, the gasket bends up. That's what gives it its integrity. In other words, that's what stops it leaking. So line up your holes. Got one slightly out of true here. So, despite all my good measurements, one is slightly out. So we're just going to trim it. Of course, the bit that we've trimmed drops down the hole. Okay. Okay. Press it in, and you will see the silver foil bend up all the way around. That's a good sign. Okay, so the diffuser and the gasket are in place, and we don't want this in yet. And then we rest this burner with the opening to see the flames at the front, and you want the heater element to be roughly to the left. You can see the holes inside for the ignition, and now you place it down until it's flat and you rotate it like that until it's now in its position. Will I say it's in its position? What I mean is all the holes line up. In fact, I'll show you better from the back. All the holes line up, spark hole lines up, and so of course does the flame rod. Once you've got that, then you want to place in your one screw at the front. This locks it in position. Now, it's all a little bit fiddly from here, in as much that the next bit is the direction flame ring. That cutout there goes against the spark eroder. And again, that should just latch into place. Indeed it has. What I'm going to try and do now, I'm going to try to change this viewing angle for you so that you can see the inside of the combustion chamber as it's being assembled. So just bear with me for a moment. Okay, that's about the best view I can get for you. It's just not easy. Okay, the next thing to do is put the flame diffuser in place. Again, the arrow pointing towards the spark. Line it up nicely. Press it into place. Okay. Well, that's in the right place now. The next thing to do is to put these 3 screws in. Now, it's really important that you get these all the same torque and actually holding it down. So we put the first one in and we check for movement, and it should be just a slight movement from side to side, showing that it's reasonably tight. Would you believe I've picked the wrong screw up? Damn thing. Right. Again, just a little movement. Then all you want next is your 3rd screw, which is somewhat eluding me. There it is. Bloody thing. Just a little movement. Next thing you do is you tighten them up. This is why in the first place I cut flats into them, so that I could get a good grip on them. That one's nice and tight. But be careful because you don't want to strip the threads. That's nice and tight. And the final one is nice and tight. Okay. Next thing to do is to put in your spark eroder. If this is slightly out of line, which this one is, just undo that front screw just there, which is directly behind the viewing window, snacking it off, pull the bottom round. like that. We'll tighten that back up in a minute. Let's drop the sparky rotor in, and its current clamp. So just put a little screw in there. Don't do it up tight because it's not facing the right way. It is now. Tighten it up. There's your ignition. And you should, on your ignition, the gap here should be almost the width of your screwdriver, because you want it to spark to this and not to the outside ring. And now for the part that's caused you all that heartache and all those E4s, which is the flame rod. Drop it in. Drop in the bracket that holds it. And drop in a screw to hold it still. Now this bit is quite important, so I'm going to try and show you it in close up. Before you finish now, just remember that you've got this front screw undone and you need to lock it up. Now then, this spark rod, flame rod, clamp it down, and you want this to be get it in there for you so you can see it. Right, you can see it just at the top of the picture there. It mustn't be touching the diffuser, but it wants to be pretty bloody close, and this one's not, so we'll just twist it, and there we've got about a 2mm gap. I don't know if I can show you it at all any brighter than that, so here we will try. Right, you see it bending over and bending round, and there's about a 2mm gap. So that's what you want. So it goes up, and it goes down, and it goes about 2mm gap. That is it. That is finally it. Take the cap. put in. And then the one thing you must remember, when you put the wires back onto the flame rod, be careful not to twist them because you've got the gap set right now. So trying to put this cover on. Screws. Don't go mad over tightening these screws. They don't need to be tight, it's just a sort of enough to hold it on. Build up this burning unit, then we're going to install it, then we're going to test it, and then we're going to take some measurements that will prove that it's working well or not. We'll just screw this high voltage unit in, which is the sparking unit. Very reliable ones. Make sure it's nipped up nice and tightly. This is the spark end of it. Sleeve. Pop it on there. Slide the sleeve down. Your next screw is for the overheat protection. Goes in there, lines up there, and has a single screw in it. That's nice and tight. Okay. This is a spark rod wire. Put it on, but do not twist it, because otherwise you'll change that gap. This is the earth wire that the spark rod wire relies upon. So you put that in there like that, so that it's nicely out of the way. Then we come to, of course, our injector. Which which is right here. This part is meant to be loose. It's for taking up slack. This part screws against there quite firmly. Three screws in total. Driver. That's nice and tight. And that's nice and tight. Do not bend this rod or damage the end of it. It goes in there. Okay. This clamps that down and holds it like that. Tighten this up. Voila! You have your now combustion chamber, and it is actually repaired, believe it or not. So let's just move this camera. Okay, so here we are again with our heater, and we're going to fit the combustion chamber. So here she is. And we hook it on the back like that. This is where we turn it around. So you can see the back of it. Lift that off. Hold this combustion chamber here where you can. And just slip that side in. So we've got those two slipped in. That's all we need. Secure it with 4 screws. Don't need to be tight. Tighten them, it just strips the threads out if you tighten these things. The steel is so thin. Just got to get past the camera for a minute, so I'll just pause that. Once they're all in, hook this up. Make sure the wire isn't stuck between it at all. One. So we go, we've finished at the back of it. Everything's clean and ready to go. That's our piece of rubber hose. Just put that down here. Fit it in at the top and then fit it in at the bottom. That's done. Secure them wires around there. And you've got this little bunch which you've got to put on. And we're going to take that one off in a minute. This is the spark rod wire. The one that's caused all the problems. Slip the over temperature thermometer in. Fit the multi-connection wire. Hook that up. This takes 4 threaded screws. Again, not tight. Awkward so and so. There we go. And if you turned it on now, it would work. Well, I'm not going to turn it on now. I'll just show you a few features. That down there is the tilt switch feature. It just shuts everything off if it tilts over. I'm just going to put these plastic clips on. Let's make sure that make sure that's tight. Just when you're looking for a tool, you can't find it. I resort to a pair of pliers. It's just a paraffin feed, but it needs to be nipped up. Right, now that's reached its temperature more or less. Now I'm going to assume that all of you have got a meter description. You need a meter that will read 50 microamps. If I turn this heater on, it's now on, hit the power button, as we all know it takes a little while to heat up. What's happening right now is that these two red wires are getting 240 volts fed to them, which is heating that ring up the cup that it goes into. The fan starts down here, and then any second now the spark igniter will start, and then the blower in the back will start. Spark and ignition. Now what would normally happen is about now you'd get an F4 fault. So I'm going to simulate your F4 fault. This is the this is the wires. I'll just zoom in on a bit. Let's take them out, and that'll make the flame go out. Flame's got out. I don't know why I said F4 fault, because it's of course an E4 fault. And there it is, E4. Because it's not happy. So, first thing we're going to do is show you what this should be reading. And to do that, I'm going to take off the yellow wire off this plug. This is always a good idea to do. That. Now put that plug back on that way, so as it's got the earth. Okay, got that. Jolly good. Now then, we get a meter. For the purpose of this demonstration, I should be using an AVO 8. Right, I've connected that AVO with the positive side going to the terminal on the board, and the negative side going down to the wire. The meter itself is on DC 0.05 amps, which is a 50 milliamp full deflection on the meter. We're not expecting that. Anything over 10 or 10 and over is acceptable. So anything there will keep on going. And it's just coming to life. Right, to do this you're going to need a diode and a resistor. The diode I'm using is simply a 1N4 148. Now take this plug completely off, and the ground side of the plug, which is the top side, you want to put the positive side of the resistor to that. So I'm going to do it in a very unforgiving way. I'm going to do it by soldering it on. So the positive side goes to ground, and then you want a 1 mega ohm resistor. For this purpose I'm using a resistor substitution box, so I'll select 1 mega ohms like that. You're going to put one contact onto the actual plug. There, the flame rod plug. Here's the diode. Oh gosh, it's out of focus. Hold on a minute. Okay, that's a bit better. So we've got the positive half of this diode soldered onto the top pin. Forget this resistor, that won't be on your board, that's just me messing around. And now the 1 meg resistor onto the flame, what was the flame rod, and then this is the other. We now turn it on. Don't leave this connected, because if you leave it connected it will just come up with a fault. It will just come up with a fault error. As soon as you hear it sparking, and then you see a flame, as soon as you see that flame, you connect the other end of the resistor, this end, straight to the back of that diode. There you are, and there's the flame. Connect that on, the sparking then goes off, and you have a flame, and that won't show an F4 fault. But now you have absolutely no protection over this whatsoever, so it's as dangerous as hell. It's only recommended to do this for testing purposes. If I disconnect the wire, the flame goes out. That's it. It's off. So I'm going to put this back the way it's supposed to be. So just bear with me. Okay, now just prop on your directional heat disperser, which is held in with 2 self-tapping screws. Pop off, take these 2 screws out the bottom that we put in to hold it stable, because they're the 2 screws that hold the front on. So now we know it's drawing more than 10 microamps, and that should be fine. Now the only thing is, that if you can't get that 10 microamps, then it's your flame rod that's damaged, and they do split. So if you have to get another one, chances are you won't get one this is the exact inverter type, so you may have to bend around a little bit and get it sorted out, but eventually you'll get one in there that's working. And that is it. I'll just turn it on when I put it on the floor to show you it working, and that's a lot. Okay, put the old fuel tank in. Turn it on. The blower started. There she goes. Short spark, perfect ignition, heat's billowing out of it. That's it. No more E4s. The only thing I would suggest is that after about 5 to 10 hours running, I know it's a pain, but take the combustion box out again and tighten the 3 screws that hold the diffuser in place. If you don't do it, you probably be fine, but sometimes that can make E4 come back if you don't do it. But this heater has been apart and together so many times, and I really hope that solves your problem, because these heaters are a blasted nuisance. I mean, the flame rod is a stupid design on these, because they use paraffin, and paraffin makes soot. The soot on the flame rod stops it working. These flame rods were designed for gas. There's no reason why they couldn't have used infrared or bimetal strips, but no, they decided on flame rods, and believe me, they can cause you a headache. So I'd like to thank you very much for watching this video. I hope it's been concise, and it's the best I can do anyway. We'll speak to you later. Thank you. Bye.